In a breathtaking achievement, the James Webb Space Telescope has once again pushed the boundaries of astronomical discovery. Its piercing gaze has unveiled a revelation of cosmic proportions: the detection of organic molecules in a distant galaxy. This groundbreaking finding opens a window into the mysteries of the cosmos. After recently discovering 6 megagalaxies that formed when our universe was a hot, dense soup, researchers have been itching to keep testing and flexing Webb's capabilities. And every observation keeps yielding results with more and more distant and ancient galaxies, each with a unique characteristic. With each discovery, the Webb telescope reaffirms its role as humanity's portal to the awe-inspiring wonders of the universe, inspiring us to unravel its secrets and explore the vastness of cosmic potential. As always, we start at the edge of the universe. It has done it yet again. Astronomers using the James Webb Space Telescope uncovered evidence of complex organic compounds, comparable to smoke or smog, in a faraway galaxy. This is the oldest known example of complex organic molecules discovered by humans in the universe. And what it has done is pushed back the existing record for detections like these by nearly 1 billion years. I'm not sure about you, but I find it interesting and alarming that these findings at the edge of the cosmos are changing the foundation of our cosmology. This is a huge breakthrough, and here's what it means. First and foremost, these compounds were discovered in an early galaxy that originated when the universe was around 10% of its present age. The carbon-based compounds, known technically as polycyclic aromatic hydrocarbons, are found on Earth in oil and coal reserves, as well as in smog. But what exactly is the relevance of this discovery? The study's chief astronomer, Justin Spiker, emphasizes that the molecules discovered are not basic stuff like water or carbon dioxide. We are talking about large, floppy molecules containing dozens or hundreds of atoms. Isn't it amazing that the cosmos could produce such large and complex molecules so fast after the Big Bang, despite our theories predicting that it couldn't? Given the galaxy's extraordinary distance, the researchers discovered light that began its journey less than 1.5 billion years after the Big Bang. The universe is around 13.8 billion years old right now. We are seeing the formation of the universe as we know it now. But there is a catch. We have been able to detect these complex chemical molecules thanks to Webb, which pushes the prior record for detections like this back by nearly 1 billion years. Imagine if we could look farther back in time. Is it possible that we find more of these molecules, and that too, extremely close to the Big Bang? Where does that leave our science, our cosmological model? Now here's the thing. Previous attempts to discover complex organic molecules in ancient galaxies could only tell whether or not the chemicals were present. With Webb's resolution, we can now see the details of where molecules are placed within a galaxy. The presence of these molecules in this early galaxy, known as SPT 041847, is not uniform, and the explanation for this is unknown. This discovery also shows that galaxies can develop in the early cosmos, where little was supposed to be happening. What's fascinating is that the galaxy was already just as huge, and its stars had created just as much carbon and oxygen as our own Milky Way, despite being only 1/10 the age of our galaxy. It's like a third grader who has already lived a whole career, gone to college, completed a career's worth of work, and then retired at the age of 8. If that isn't enough to pique your interest, this discovery also disproved another notion. Previously, scientists believed that these complex chemical substances were linked to star formation. However, recent research suggests that this may not always be the case. Spilker and his colleagues discovered many places with these compounds, but no star formation, as well as other regions with new stars but no of these molecules. According to the conventional cosmological model, the first stars formed between 500 million and 1 billion years after the universe arose from the Big Bang. That, however, is changing.
Well, that's the problem. The James Webb Space Telescope is upsetting the apple cart. All of a sudden, we realize that we may have to rewrite all the textbooks about the beginning of the universe. Now, it takes many billions of years to create a galaxy, like the Milky Way galaxy, with 100 billion stars, many billions of years old. But the James Webb Telescope has identified 6 galaxies that exist half a billion years after the Big Bang that are up to 10 times bigger than the Milky Way galaxy. That shouldn't happen.
We are not just finding single stars, but clusters of them in the early universe, and that has the whole scientific community stunned.
So now, let's tune the telescope in to galaxies being born. And oh my gosh, who ordered this? We're finding galaxies in the Dark Ages.
The star clusters in question are called globular clusters, ancient celestial enclaves born approximately 13.4 billion years ago. They are not only the most massive and ancient star clusters, but they also have a unique feature: compositional variation among their stars. Consider this: stars born side by side from the same cosmic womb of collapsing gas and dust. Despite their common origins, they differ significantly in the amount of components such as oxygen, nitrogen, sodium, and aluminium. This enigma, known as abundance anomalies, has perplexed astronomers for years, challenging their attempts to decipher the cosmic puzzle.
Something is wrong. We may have to revise our theory of the creation of the universe. Now, I personally think that the solution to the problem is these are not baby galaxies at all. They're actually monstrous black holes. Black holes that formed after the instant of creation. That's baffling scientists because they don't fit in the normal sequence of the birth of a galaxy. So I personally think that we're actually looking at monster black holes where perhaps new laws of physics are emerging. And again, if you can figure all this out, there could be a Nobel Prize waiting for you.
Undaunted by the difficulty, the research team sets out to discover the telltale characteristics of these enormous stars. They use the James Webb Space Telescope's infrared vision to look for globular clusters in their early phases. They use the telescope's incredible powers to peek into the furthest reaches of space and focus their attention on GNZ 11, one of the most ancient and farthest galaxies known to humanity. Situated a staggering 13.3 billion light-years away, JWST captures the galaxy in its infancy, a mere few tens of millions of years old, making it an ideal hunting ground for young globular clusters. It is the distinct nature of light that guides their investigation. Chemical elements possess unique absorption and emission patterns, leaving behind fingerprints that reveal the composition of celestial objects. The astronomers meticulously break down the light emanating from GNZ 11, unearthing 2 vital pieces of information that propel their quest forward. We have determined that GNZ 11 contains exceptionally high proportions of nitrogen and an abundance of stars, remarks Daniel Schara, a distinguished member of the study team and an astronomy professor at the University of Geneva. These findings create a vivid picture of the formation of numerous globular clusters and the presence of active supermassive stars within GNZ 11. They will extend their view to distant galaxies, investigating other globular clusters and looking for patterns that confirm their beliefs, using the James Webb Space Telescope as a guide. The enormity and intricacy of the cosmos humble us as humanity travels into the unknown, armed with information and a hunger for understanding. And with each breakthrough, we get closer to unlocking the mysteries hidden among the stars. With the way Webb is performing, It is only a matter of time before the universe shines in a new light. So, would you like to travel to the other side of the universe, or stick with us here, at the edge of the universe? Until we meet again.